Hi, this is Mrs. Basin. Today we're going to go over some examples for the writing equation practice. So before we get started, there's a couple things we want to review because when you're translating these descriptions of chemical reactions into the chemical equation, there's a couple things you have to remember. So we know that the reactants go on the left and the products go on the right. But the other thing we need to add in there is the state of each reactant and product by using S, L, G, or AQ. So S is a solid, L is a liquid, G is a gas, and aqueous is AQ. That just means something is dissolved in water. Most of the time, this is going to be included in the description of the reaction, but you can also refer to the periodic table. If you remember our periodic table, the solids have black letters, the liquids have blue letters, and the gases have red letters. So that can help too if something's missing from the description. There's a couple other symbols you need to include. So if the reaction is heated, if heat is applied somehow to make the reaction take place, you put a delta sign or a little triangle over the yield sign. And if there's a catalyst used, you write CAT over the arrow. If you know the identity of the catalyst, then you write whatever the chemical formula for that catalyst is over the arrow instead. So we'll talk more about catalysts later, but you saw when you did the lab that it speeds up the reaction, but it doesn't actually take part in the overall chemical equation. So you don't see it in the overall chemical equation, which is what we're writing. Okay, so this is our first example. If it's something that I know you won't know the formula for, then I'll give you the formula. So like in this case, I give you the formula for methanol. But most other things you should be able to figure out using your polyatomic ion sheet and using all those rules that we've talked about in the past for writing chemical formulas. So this one says methanol is an important industrial chemical. Methanol can be synthesized from carbon monoxide gas and hydrogen gas under certain conditions of temperature and pressure. So what you have to figure out from this is what are the reactants, what are the products. So you're going to look for some keywords. So synthesized is a key word here. So if it says methanol is synthesized, that means methanol is a product. So the methanol, and again I give you the formula here because I know that's one that you wouldn't know how to write. So methanol goes on the right as a product because it was synthesized or produced. It was synthesized from carbon monoxide gas. So carbon monoxide I know is CO. And it tells me it's a gas. So I'm going to put the little G there. The methanol, if you can see in the container down here, you can see that methanol is also a liquid. So we can put that there. And then the other thing it's synthesized from is hydrogen gas. So hydrogen gas, if you remember, is one of those diatomic molecules. So anytime you have BRINCLHORF, if they're by themselves, then they're always paired up. So these are the ones we talked about that either make the word Brinkelhoff or they start at number 7 and make a 7 on the periodic table. So we've talked about those before, but now we're kind of coming back to the application. So since it says it's hydrogen gas, then I have to write that as H2. The last thing you would have to do would be come back and balance this. So I'm not going to balance these, that way you can go back and do that. So don't forget you need to go back and balance this one, but that's a good example of that first equation. Okay, for our next one, it says phosphorus trichloride is used in the manufacture of certain pesticides and flame retardants. Liquid phosphorus trichloride may be synthesized, so there's that word synthesized again, directly from its elements. So I know that phosphorus trichloride, so that's going to be PCl3, is synthesized from its elements. So the two elements that make up phosphorus trichloride are phosphorus plus chlorine. But remember, chlorine is one of those diatomics, so it's going to be Cl2. Okay, so liquid phosphorus trichloride, so that becomes a liquid. Chlorine is gas. If I look on the periodic table, and if I check phosphorus on the periodic table, it tells me it's a solid. Again, you need to go back and balance this one, but that's example number 2. Example number 3 says nitrous oxide gas, or dinitrogen monoxide, is used by dentists as an anesthetic. So this is what sometimes people call laughing gas. Nitrous oxide and water vapor can be produced in small amounts in the lab by careful heating of ammonium nitrate. So the nitrous oxide and the water vapor can be produced. That tells me those are products. So nitrous oxide, again, is dinitrogen. So N2 monoxide is O, and this is a gas. And water vapor, so water we know is H2O. If it's in the vapor form, that means it's a gas. And it's produced by heating ammonium nitrate. So ammonium, remember, is NH4 and it's a +1. Nitrate is NO3 and it's a -1. So NH4, NO3, and that one it doesn't tell you specifically, but that's actually a solid. So when that's heated, that produces NO2 gas and H2O. Now the other thing about this one is we see this word heating. So if it tells me it's heated, that's where I put that little delta sign or triangle over the yield sign. Again, make sure you go back and balance this, but that will at least get you started with the reaction. Okay, example number 4. Hydrogen sulfide gas is responsible for the odor of rotten eggs. Hydrogen sulfide burns in air, producing sulfur dioxide gas and water vapor. Okay, so this one says I'm starting with hydrogen sulfide. So hydrogen's a +1, sulfur's a -2, so that's going to be H2S, and it's a gas. Burns in air means that it's reacting with oxygen gas in the air. And it produces sulfur dioxide gas, so SO2 gas, and water vapor, H2O liquid. Okay, so this one burns in air to produce sulfur dioxide gas and water vapor. So this one, because it doesn't directly say you're heating it, you don't necessarily have to have the delta sign there, but you could put it there if you wanted to. Again, don't forget to go back and balance this one. Okay, last example we're going to do together is number 5. So this one says acetylene gas, which is C2H2, is used by plumbers, welders, and glassblowers because it burns an oxygen with an intensely hot flame. The products of the combustion reaction are gaseous carbon dioxide and water vapor. Okay, so it tells me that this is a combustion reaction, so I'm reacting the hydrocarbon acetylene, so C2H2, which it tells me is a gas. It burns an oxygen, which means it's going to react with O2 gas, and it produces, or the products are gaseous carbon dioxide, CO2, plus water vapor, and again, water vapor means that's water in the gaseous form. Again, on this one, make sure you go back and balance. You could put the heat there if you wanted to, because usually these reactions are heated to get them started. And again, make sure you don't forget your states of matter. Okay, so balance, and then you are good to go. Okay, so for the rest of these, that was the front side of the practice. So for the rest of them, work through those, do the best you can with those, and then we will work through some more examples tomorrow.